Hello and welcome to the .next Moscow 2021. We are back online and broadcasting to you with a lot of useful and interesting content. And I would like to present you our first speaker here. It's Oren Eini, which you may have already seen in the spring season. And hi, Oren. Welcome
Hey,
back to .next.
thank you very much.
So how are you these days?
I'm doing very well, doing a lot of interesting stuff.
Yeah, for sure. And with the approaching the release of .NET 6, which I'm sure will affect something that you
I'm
do.
looking forward for that. Yeah.
Yeah, everybody is. So I have a question to you. So in
Mhm.
the spring season, you were giving a talk about the database internals, like all these low-level stuff, like how data is organized internally, B trees, and uh, different things like that. And this time, you're back to .next with a pretty high-level talk about the architecture and how to organize, how to build the whole system. So how do you combine this like deep dive low level knowledge with the high level architectural approach? So what kind of person are you?
One who looks for solutions. Now, that solution may be at the lowest level, let me optimize how bits gets to the disk, or it may be at the highest level of let's work on a distributed architecture and see how it works. The surprising thing about that is that for a lot of those scenarios, the answers and approaches are basically one and the same. The and when you look into building non-trivial system, you realize that you have to have call it a breadth of knowledge across what is the impact of this decision. And that may be, oh, I'm making a remote call, or oh, I need to uh, uh, save some data to the disk. If you actually look into how a modern machine is composed, this is actually can be considered to be another distributed machine, because the scenario is that okay, I have the CPU, and going to the disk or going to the memory even is such an expensive operation that you spend a lot of time thinking about locality. And then you move out from a single machine into a cluster of machines, and you realize, okay, a lot of those concepts are still the same. And when you think about how do I solve a problem, then you have to have the ability to look at it from here to here to understand how it goes. And in some cases, even what appears to be minute changes at the lowest level of the system is going to have a huge impact on the overall architecture that you have. To take it as a trivial example, if you have a solution that provides you with ACID transactions, that has an impact on your architecture, even though this is about as low level as you can go in terms of storage details.
Mhm. Yeah, that's an interesting viewpoint. I have never thought about that in that aspect. Like many people think like you either approach the system like first at the large scale and then you dig deep dive into the technical details. But yeah, you should combine that always. So today you will be talking about the high level part, I assume. So let's just get going and listen to what you have.
Great. So I'm here today to talk about building a loud social network. Now, I chose social network to talk about for a bunch of reasons. It is a relatively simple model to talk about. I'm assuming most of you are familiar with. It allows us to deal with big scale in contexts that make it challenging. Having to handle 20 terabytes of data, or oh, I need to crunch through past transaction to find the appropriate recommendation to user. Okay, lots of data, but it's not really that interesting. Having to have a reliable system around the world handling tens or hundreds of millions of users is a lot more challenging. Uh, I'm going to use real world examples Uh, I'm going to throw a lot of numbers. This is recorded. Feel free to watch and look at this later. Uh, if you have any questions, please raise them during the talk. I find it much easier to do it this way. Now, let's look at this. About not even a year ago, there was a social network called Parler. It was supposed to be a free speech one. It's become a wholly political issue. I don't care about this. I care about the actual technical details. And the technical details that at some point in early January, Parler was told, get off our lawn. You have Apple and Google remove it from the app stores. AWS told them you have 24 hours to leave, etc. Which meant that Parler went around and start shopping for someone who can give them the infrastructure that they need. And this is interesting because that also revealed to us what is their backend infrastructure. Here are the details. So they have a scalable. This is a Cassandra clone written in C++, supposed to be much, much faster. Postgres and some applications. I want you to look at those numbers. 40 Cassandra nodes, 100 Postgres nodes, and 400 application servers. Now, look at the specs on those systems. I did them at here, and this is ridiculous. Absolutely, utterly ridiculous. Now, they are paying Amazon upward of $300,000 per month. I went and spec'd out how much it would cost to buy this thing. To be fair, I did it in January, which means that given the chip shortage, we're probably looking at higher numbers today. But the amount that we're looking here is ridiculous. And why is it ridiculous? Because the math doesn't hold up. You're paying Amazon $300,000 a month. Then at the peak, they had about 13 million users. So 2.3 cents per month per user. And if I'm a venture capitalist that is trying to look at engagement numbers, maybe it makes sense. If they made money from that, apparently ads or whatever they were doing, and they were profitable, more to them. But from a technical perspective, I'm looking at those numbers and I'm going, what are you doing? This is wrong. Just look at those numbers. 400 application servers. Let's do some math, okay? 400 application servers. Let's assume that each one of those servers can handle just 2 requests per second. That means that in the space of 24 hours, they're supposed to be handled 70 million requests. Now, 2 requests per second is a horrendously low number. I have a Raspberry Pi here. I don't know, I haven't properly introduced myself. I'm Oren Eini. My day job is to build RavenDB, which is a NoSQL database. And I have a Raspberry Pi here, Raspberry Pi 400, which has 4 cores, 1.8 gigahertz, and 4 gigabyte of RAM. And I can process 500 to 750 queries per second on the Pi while running on a SSD drive. So saying, oh, you can process 2 requests here for a total of 800, 1600 something here is just utterly insane. That means that their architectures and approach are wasteful. Let's look at real numbers. I went and looked at Twitter's. So Twitter has lots of users, about half of them are active, but the things that we care about is who generate the content. So 10% of the users generate 80% of the content. We're talking about around 10,000 tweets per second. I actually had to go back to 2013 to find the maximum number of tweets per second. So those are very respectable numbers. Having to process 10,000 writes per second is something that, to be fair, I would struggle with on the pie. But give me a commodity machine and I can do that. Now, I cannot do that over a 10,000 a second. We're talking nearly a billion writes per day. Multiply that by a year, and you start talking about real numbers. So at that scale, you need to have good understanding of what you're doing, what your hardware requirements, those sort of things, but not to the level that Parler had. Now, here is something really interesting. A tiny minority of the accounts have a large number of followers. In fact, very small numbers has a large number of followers at all. And most users don't really tweet that much. So let's say that I'm sitting now to design a new social network. By the way, quite amusing. Today, Trump announced that he's building a new social network. So apparently, if he's listening to this talk, I will tell him how he can save a lot of money. Uh, so here we go. So we want to build a new social network. Our goal is 50 million users within the first year or two, and we're going to specify that this is a highly engaged environment. 50% of the users are going to post at least once a month. So think about what it means. It means that 25 million users are going to post. The rest are readers. That's okay. Now, a vast majority of them are going to post very little. Oh, I ate this nice pie. Or I got in the morning and went to a run, those sort of things. Uh, Most people are going to post small number of posts during the month. So 300 posts is extremely active a Twitter account, for example. So I'm going to say that this is not the case. Some people are going to post a lot. I actually went and looked into the Twitter statistics. Uh, and I looked into some of the most common news events, and I looked at journalists. And journalists use Twitter a lot, and they post and they tweet and retweet, almost stuff like that. So the maximum I could find was one guy who posted 350 tweets in a day. Let's say that we're going to be more pessimistic in that. We may have users who post 500 times a day. By the way, the actual limit for Twitter is 5,000 per day. So looking at this number, I'm doing some math, and that means that I need to handle 1.7 billion posts per month. This is a respectable amount. How do I do that? How do I approach something like that? So let's break it down. 1.745 billion posts a month, end up 670 posts per second. 670. That's an interesting number. Remember, going back here, I have 100 Postgres servers. Assuming that they store the tweets here, can Postgres handle 6.7 writes per second? Well, yes, it can. It can handle 670 writes per second as well. So we have to figure out, okay, what's going on? How do we manage that? Now, the truth about this is that this is an unfair statement. I'm not going to talk about consistent load. Again, looking at some numbers in the Super Bowl 2016, we had 1 minute with 152,000 tweets per minute. And in 2013, there was this maximum of 149,000 tweets per second. So the issue is that we have huge variability there can be some sort of a news event, and everyone is posting about that. So we may go from a few hundreds per second to tens of thousands, like that. So how do we manage that? One way of doing that would be, okay, let's get all of the spare capacity that we have. Let's run hundreds of Postgres servers. Let's run them on really, really big machines. Let's just, burn money. It's the VC money. I don't care. So let's try to talk about the actual scenario that we have here, and I want to limit what I'm going to discuss. I'm going to discuss posting of text, of tweets, posts, whatever. I'm going to ignore anything related to media. There is a lot that you need to do. You need to re-encode, you need to verify that someone didn't post copyrighted music, you need to strip a whole bunch of stuff. The issue of sending large files to users, all of that, I go to Cloudflare. I go to some CDN. They have built-in services directly for that. I provide nothing major. I have no competitive advantage in sending files around or outputting a lot of data. Not my deal. Here is what I want to do. I want to process all of the posts and reads in the social network. Showing a video, it's about just give me the HTML, the link that I need to download the video. That's about it. So let's look at what I'm saying. What I'm going to do, I'm going to specify the capacity that I require on the system. And I want to head in terms of write 5,000 posts a second. This is the limit that I'm willing to accept. Under 5,000 posts per second or less, I'm guaranteeing 99.99 percentile at under 200 milliseconds. Now, this is how you write a service level agreement. What this means is that under this condition, load under 5,000 posts per second, out of every 10,000 requests that I'm making, only one of them would take more than 200 milliseconds. Now, notice that this is about writes. We also have to deal about reads, but reads are easier to scale. We'll talk about this slightly later. Now, handling 5,000 writes per second is a challenge, especially because I'm not just ingesting the data and throwing that somewhere. I need to send it out to users as soon as possible so they can see that. I need to do push notification, all bunch of stuff like that. So let's think upfront what we need to do. How do I make this happen? And the idea here is that we start from the overall design. If you look at Facebook, Facebook has multiple types of content. You have the post and the reply to posts. On Twitter, everything is a tweet. If you retweet, this is just a tweet with a different metadata. A mention is the same. So if everything is homogeneous, everything is the same, it's easier. We're going with that. The idea here is that we have a post. The post may contain link to another post. It may be a mention, a reply, whatever. Doesn't actually matter for us. Still a post. Our architecture is going to favor reads over writes. Even when we talk about something that accept 5,000 writes per second, we're still talking about far more reads. So another thing to remember is that the overall performance is hugely important. And there's been many studies about latency and what sort of impact it has. Amazon tested that adding 100 milliseconds to the page load time reduce the number of people who bought by 1%. Now, this is interesting because 100 milliseconds is below the conscious threshold for people. So you wouldn't notice that consciously, but it still has an impact. So we absolutely want our reads to be as fast as possible. At the same time, we are favoring the user experience. Consider what it means for Twitter to lose a tweet. I tweeted and it's gone. Not fun, but the sky isn't falling, especially if this happens once every year or two. So we're going to cheat. In fact, we're going to cheat a lot. And this is not quite cheating. The whole idea is that we're going to give the user immediate gratification. You hit it and it happened. The fact that there are backend processes that happen behind the scenes that will take some time, unrelated and quite expected in a distributed system anyway. So let's talk about how I'm going to build it. I selected 4 different core components. We have the CDN, the content delivery network. This is how we push media out, files. Again, not my core competency. Someone else is going to handle sending data out. We're going to use S3 compatible. There is now the R2 from Cloudflare. There is the Backblaze guys who are also offering a far cheaper option. And S3 has become, the S3 API has become effectively de facto standard for object stores. We're going to use distributed key value store and a distributed queue. Now, the key about all of them, they are extremely limited in what they offer. Because they are limited, they are very easy to scale. If I want to have a distributed key value store, well, give me as many machines as you want. I would shard the data among them. I'm done. I actually have a bunch of talks where I build a distributed key value store within an hour. It's that simple. Now, for production, it's a lot more complex, but it's still that simple. Same thing for distributed queue. It's one of the most trivial things to do in a distributed fashion. Now, I've chosen them because they're easy to scale. That put limit on myself. Oh, I cannot do more fancy stuff. That's okay. I'm explicitly trading off my capabilities in order for me to deliver results to the user faster. And explicitly, if it's hard, let's not do that. It turns out there are some things that are supposed to be hard, but you can make them very easy if you change the way that you perceive things. Let's see how that works. So here's the deal. I want to make a post. So as the client, I take my application and hit post. And this sends it to a server somewhere. And the only thing the server does is put it in a queue. And then it returns to the user, says, okay, success. Now, my application, my app that's running on the phone is going to say, okay, I got a reply from the server. I'm going to immediately show to the user that it was posted. This is purely client-side behavior. This is what I meant about cheating and favoring the user experience. The only thing that I needed to the server for to confirm that it got the message. This is because I may be disconnected, offline, those sort of things. I don't want the user to think that they can post if they're offline. Maybe in some cases I would add it to a queue, to a local queue. But in most cases, if the server got it, I'm immediately showing the user that he showed up. I'm putting that on the timeline. Everyone is happy. Now, why am I doing that? Why not do the actual work? And the answer here is that it's too complex. If I did all of the work that I need to process a post while the user is waiting for confirmation, that would give me a hard timeline. Remember, I have maximum of 200 milliseconds to process the request before I have to say, hey, I posted that, or you know what, you just posted about broccoli. Broccoli is forbidden from discussion in this social network. So I want as much as possible to ignore all of that. My queue, my server is going to take the message, do the minimal of validation. Is this the probably just authenticate the user and just throw that to the queue and that's it. And it's trivial to scale distributed queues. And that means that this gives us a really, really important property. I have time. I have time to now process the post without heavy significant time pressure. Now, let's say that this is now Super Bowl 2016, and I have to handle 150,000 posts within a single minute, in addition to all of the usual traffic that I have. I throw everything into the distributed queue. At the same time, the usual workers who pull from the queue are just churning as they usually do. Worst case scenario, I have no to scale, I'm not responding to that. It may take me 10, 15 minutes to process all of that. The user who posted is actually able to see that they posted immediately. Other users who are watching all of that, what's the SLA for them to see my posts? It turned out that the SLA from Oren posted a new post to you who is following me, seeing that can be quite high in the order of minutes, hours, if necessary. And because I have a queue, it's trivial for me to decide, oh, I can see that the amount of items in the queue is growing. Let me add additional workers. Oh, the queue is nearly empty. Let me reduce the number of workers that I have. So the issue, the complexity of spinning up workers up and down, processing the load, all of those sort of things is becoming drastically simpler. What about the server that is accepting the new posts? Well, what is it actually doing? Get a post, validate the JSON, validate the user, both fairly trivial things to do, and throw that into a queue? If you cannot handle tens of thousands of requests like that per second, then we should have a talk because it's not that hard. So now we have a facility to flatten out spikes. We have the architectural concept of how to handle higher scale. And we gave ourselves time to manage things. In fact, we gave us time to manage things immediately and time to manage things in the future. For example, let's say that the business come and tell me, hey, I would really like to be able to do, I don't know, machine learning replies, whatever, something Bitcoin as a service. Pick your buzzword, basically. And that's something that adds potentially 5 seconds of processing time per post. I can send them, okay, no problem. As part of the background processing of the post, I'm going to throw that into do slow stuff and then just handle it that way. I'm not committed to doing everything in the main path. The user doesn't see any of that. So let's talk about other design decisions that makes my life easier. So we start from all data is a post. This is a JSON structure. This is so we can modify it over time, obviously. And the whole idea is that the post has an ID, and the only way to get a post is by ID. Why is that? Because that's simplifying my architecture. Now I want to be able to search. I want to say, give me all of the posts by John Doe, or I want to give me all of the posts about Super Bowl 2016, or search by a hashtag or something like that. How do I do that? Well, the answer is you don't. You don't do that on top of the same infrastructure. What we'll have instead is okay, we have the usual mechanics in which we are streaming data into a we're streaming the data into the queue and into the key value store and all of that. And then we have background processing that says, okay, let's enable a search by e tags on that, search by a hashtag on that. And I will actually have a proper example of how this looks shortly. But the whole idea is that we accept the limit only fetching by ID. You want to fetch by something else, you have to go somewhere else to do that. Another very important consideration is that we don't allow edits. A user may decide to delete a post, but we don't allow edit. Why is that? And the reason for that is quite simple. If I allow edit, then I have to deal with complex distributed state. If I, for example, consider to have two edits to the same post at the same time, one here and one here, on different regions or environments, which one is the winner? What happened if it got replicated to other regions? It makes it harder to do. So my reaction is, okay, we're not allowing edits. We do allow you to delete because the scale out model is much easier. And if we have replication and we have an edit, we have a post and delete, the delete always wins. And a key value store, especially because we only have an ID, is trivial to shard, to scale, to replicate. It's going to be really, really cheap to operate. Something to remember, we may end up with billions of posts over the years quite easily. We saw that we have 1.7 billion posts per month. So that's pushes to close to 15 billion a year. But I don't need to keep all of them in memory. Only typically only the most recent ones are in memory. So I can get big disks and lots of hardware and run on that. And lots of hardware means 30 machines, not hundreds, even at that scale. So let's talk for a second about IDs. Now, Twitter is using something called Snowflake. This is 63 bits number. They generate on milliseconds from epoch. This is a distinguisher on the number of machine. They have a maximum of 1,000 machines that can generate IDs. And this is a sequence that they can generate multiple IDs per second. The nice thing about it is that it generates sequential IDs. And I talked about this previously in the database internals talk. Sequential IDs are really, really nice for optimizations. This allows us to generate IDs on multiple machines very easily. However, IDs aren't secrets. You can guess them. In fact, if you go to this thing, you will see that this is a tweet that quotes itself because this account basically guessed what is the next tweet ID that will be generated. Now, that might be a problem. If we have predictable IDs, we may be subject to scanning attacks. And going back to Parler, they actually had something that generated sequential IDs, and there was actually an attack by many people who run this code, and it went and started grabbing a lot of the content of them in a distributed crawling effort in order to get 70 terabytes of data out of that. Now, recently there was this huge brouhaha on about Facebook where they were talking about millions or hundreds of millions of personal details were exposed. That was the personal details that he posted, that people posted about themselves. But if you look at that in bulk, that can still be sensitive. And that's something that we don't want to do. We want to say, okay, if we have predictable IDs, we have to implement rate limiting, authentication, all bunch of other stuff like that. That's complex. That's hard. Let's not do that.
Oren,
Instead, yes.
we have a question actually in chat with a little bit previous topic,
Uh,
but it might be very interesting to discuss.
mhm,
So you said that, okay, let's assume for the simplicity that we do not have the edit operation. But the question is, what if we replace the edit operation like under the hood with the delete the tweet and add the new one? Like we do have deletion, so
mhm.
let's just simulate editing by delete and add the new one. So what would be
That would
your
that would generate a new ID. If you generate a new ID, then what about all of the other users who have linked to that, retweeted that, quoted that, all sorts of stuff like that? That's a major issue, especially because you have to consider certain nasty behaviors around social media. Let's say that I post uh, I'm posting a picture of a flower or a kitten. A kitten is great, and I get lots of response. Oh, this is wonderful, and stuff like that. An hour later, I edit my post to show you a post of a broccoli, and suddenly you posted that you like broccoli, that you like that I like that my post about broccoli. At this point, the community says, "Oh, you're a broccoli lover, throw you out the window," stuff like that. So this is not necessarily a technical only decision, but this is also a social and a aspect of can you modify what you posted after other people have talked about it.
okay? So basically, you can simulate this delete and then the new one like manually doing it with your
Mhm.
client application. So maybe yeah, it's fine. Okay, thank you.
Okay, so going back, now we are talking about IDs and how I would suggest you would handle that. So the first thing is that instead of using 64 bits or 63-bit number, we're going to use 16-byte number. So 64 bits is 8 byte, we're using double that. Why is that? Because it used to be the case that numbers were preferred for human readability aspects. But I want you to look at this. Does this number tell you anything at all about what this is? Probably not. It doesn't actually matter. So I might as well go and use something that is machine readable and operate on that. So here is an example of encoding a 16-byte unique value using base 58. This is your LSF. You can more easily read it over the phone and stuff like that. But basically, some random 60-bit number. Now, I still want it to be sorted. I still wanted to allow me to generate it on independent values. So I'm doing something like this. First 24 bytes, this is the time in minutes. This gives me a cycle of about 31 years, more than good enough. Next 20 bits is the machine ID. I have enough here for all of the machines that I want. This 20 bits I'm going to reserve for flags. Notice that this means that just from the ID of a post, I can tell if this is a public post or a private one. That can be really nice to have. And then I have 64 bits of random crap. Basically, I'm just generating some random numbers. This is to ensure that uh, I'm not going to have any duplicates around that. The chance of an actual collision here is uh, 1 in 4 billions or so, assuming birthday paradox. And this is only on this machine, and I can quite easily check that on a per minute basis. So the whole thing can be computed really cheaply and without having to really think about what I'm doing. And once I have that, and remember that I also have another 20 bits, 19 bits that I can use to say things directly in the identifier. That's going to be really nice because it means that, oh, I have term limits. I don't need to worry about term limits. I don't need to worry about people guessing the IDs. The key space here is uh, 2 to the power of 64, which is big enough that I don't really need to worry about it. It's not certain. You might actually be able to guess that. This is not cryptographically certain, but it's big enough that I don't care. And you guessed one or two, I don't care. This is a public post and you're scanning over that anyway. So now let's talk about what it means. One of the costliest things that you can do is deal with permissions. So instead of dealing with them explicitly, we're going to say, okay, most of the posts are public. And all of the popular posts are by definition public. So I can look at the ID and just skip all of the permissions directly from the ID that I got from the user. And only if this is private do I actually need to do a certain check. Now, here is the way that I'm going to read posts. I'm going to have an endpoint. It's going to accept multiple IDs. I'm just going to get it. It's really important to understand that for the most cases, I'm going to get a batch of IDs all at once. This comes back to the fallacies of distributed computing. You want to be batch oriented. Because this is a GET request, I'm naturally limited, and I can limit that to 256, 512 numbers of items that I'm accepting here. It also means that, oh, I can very easily manage to do all of that internally without really thinking about it. Media is again through CDN, and the posts are loaded directly from the key value store. And again, super cheap to manage. Now, here's where it becomes really interesting when we start talking about data distribution and mutability. Let's assume that I have all of these data centers and I want to load a particular ID. In this case, not that I'm getting one ID in particular, I would probably get a bunch of them. But so I know that the post can never change. Maybe deleted, but never change. So it's trivial for me to propagate changes. Look at what we have here. This is my local key value store. Do I have it? If I have return, I'm done. Otherwise, I'm going to split the ID to check the time, machine, flag, and unique. This is the crypto stuff. Based on the machine, I can find what data center I'm at. If this is my data center, I know this is a missing value and I can just return it back. Otherwise, I'm going to go to the remote value, remember it here, and go out. So something to remember, most of the posts are local. If I'm posting about, oh dear God, the traffic is horrible in Chicago, or look at the beautiful snow in Moscow, probably someone who live in China doesn't really care, or we never even see that. So I posted this here. It's going to stay here. If a user came to this data center and wanted, oh, I need this ID, I would try to get it here, couldn't find it, realize that this is the owner for this post, go directly to it and fetch it. Now this is cached here. And now I'm done. Next time that someone would get it, I'm going to get it from here. Now, that means that any popular post is going to propagate across all of the environment. It means that from a conceptual point of view, I don't actually care about replicating data across multiple environments and data and regions, stuff like that. I would probably say that, oh, this location would be in this data center here, but conceptually they're the same data center because this is Central Europe, East Europe, etc. And people from New York aren't likely to say, "Oh, I want you to." I'm really interested in what happened in St. Petersburg today, or something like that. Now, the next stage is how do I handle deletes? And we're going to run into problem. Synchronizing distributed state is a pain, real pain. So we're not going to do that. We're going to assume that deletes are rare. But the edge cases are typically where it hits us the most. So what I'm going to do, I'm going to say, okay, let's delete a value. If this is mine, if it's not my data center, not the owner, I can do that. If it is, I'm putting in the delete marker, and then I'm queuing a delete command to all of the data centers. Now, notice that this data center may never have this ID. I don't care. I'm sending that anyway because it's simpler and cheaper to do so. Another thing to remember here is that I may have a issue with propagation of data. So it may take some time to delete, but it is okay. This is how any distributed system works. When I'm embracing that, I'm realizing that I can have a much simpler architecture and options. Now, so far I talked about a single document, single post.
Oren?
Yeah, yes.
Yeah, now we have the next question, and it is related to posting tweets. So, will
Mhm.
you have anything detailed about how you post in the remaining part of your talk, or we can
Yes,
cover the post part now?
yes. I'm going to talk about it in just a
Okay,
little
then we will postpone the post question until
bit.
that
Okay.
time. Okay.
So so far I talk about how do I read a single post, but a single post I need to see the timeline. So we need to realize a core concept is also the timeline abstraction. So we're going to say, okay, I have a timeline where I last read, and this is just a pointer to a timeline location. If you're familiar with how Kafka works, this is very much how it works. A user have a public timeline, all of the public post operation that he did, and a private, all of the things that happen to the user. Oh, John has posted. So I'm going to see, oh, you're following John. I'm going to add the post from John to your timeline. And the timeline is just a list of all of the post IDs that we have. So this is how I'm going to handle any post. Remember, this is from my perspective, I put it in a queue. And after I put it in a queue, now I'm handling that. So I have the ID generation, I'm generating the post, I'm putting the post in the local key value store, and then I'm starting to put it in the timelines. This is the timelines for the user. So all of the posts by a certain user, by the user who actually did the post. If this is a public post, let's put it in the global timeline of the entire system. If this is in a reply to a post, notice that there is a timeline for the post itself. This is the idea of the post that I'm replying to, and this goes into here. If this is a celebrity, there is a separate handling. But if this is not a celebrity, then that probably means that you have under 1,000 followers here. So I can just add that to their own timelines directly. And the overall concept is that this is what you have. You have a timeline ID, the name, and the post ID. And this is an append on the structure, and we're going to have potentially billions of them. Conceptually, we have a timeline for each post in the system, for each user, for each thread, etc. So when you add to a timeline, we just add it until we get to a certain size, and then we create a section, throw that into a S3 or similar, and this is now frozen. The idea here is that effectively, again, going to the batch-oriented mode. Post, 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 hit a certain size, throw that and clear. Flash that into a section and then read from there. Here's how it works when we read it. You go and say, hey, I want the public timeline of John Doe. So this is the timeline ID. And here are all of the individual posts that you have. This is the most recent post in the timeline. Remember that you use this to go and fetch that from the batch-oriented API. Here is the last 256 post for this user. Now, if you want to go and look at the history, that's here. Now, this is probably going to be about 8 kilobytes, probably less. But as you can see, this represents quite a bit of history. And that's really cheap to do. Most of this is mutable. And something that is really important, if you're talking about something like John Doe public timeline, remember that I can put a cache on this value and cache that, let's say that I'm caching that for 1 minute. And even if this is an extremely popular account that posts a lot, well, this is cheap, this is trivial. The entire system lends itself to caching, to operating things at much cheaper things. Now, the section can go to CDN, and I don't even need to touch that anymore. I just refer to that from that point on. When I read the timeline, I do everything from the client side. So if the client is doing that, I don't need to pay for all of this. And because this is batch oriented, this is really cheap. And the section that I have, this guy, this is just a list of all of the post ID that I have. Maybe compressed, maybe something like that, but that's about it. Now, let's talk about how can I implement something like a hashtag. Here is the post.
Maybe,
Yeah.
Oren, maybe
Yes.
that's the time to get to the posting. And the logic that you've shown on the slide, analyze the number of followers, put the different
Mhm.
timelines and everything. As far as I understand, this happens already when the post is extracted from the queue and
Mhm.
processed.
Yes.
But the
Yes.
question from the audience is that uh, we assume that probably posting itself and putting this post into the queue
Mhm.
requires some kind of validation. So what if we need to, so how to decide how much validation we need before even putting the post into the queue and responding to the client that yes, this is posted, because there might be something that is, well, the post violates some rules. And so we showed it in the client tab that, okay, it's posted, but later on backend will say, nah, it's invalid and it's
Mhm.
removed. So how to solve
Yes.
that?
You so the idea here, this is probably wrong. This should be generated. The ID is generated when you actually submit the post.
Hmm?
At which point, what you're doing then, you have an ID that the client got back and is familiar to it, and this is what you do from this point on. You're saying, okay, I posted that. The user interface has immediately show it on my timeline,
Hmm?
completely client-side operation. I pulled that from the queue and realized, oh, you're posting about broccolis. We don't allow that. I'm going to delete that and I'm going to insert a message, a post into the private timeline of the user saying post so and so was rejected for violating our community standards, something like that. So the whole thing is asynchronous in nature. Now, this is me choosing to follow the happy path. In most cases, I'm going to say, hey, you know what? You're going to accept the post.
Hmm?
And if you have a user who keeps sending broccoli pictures, then, well, they suck. We don't care about them that much. Uh, and for the most cases, what is going to be the amount of time that you have from posting the message until it is processed? Well, you have two options. Either this is trivial operation, such as, for example, search for broccoli, analyze for, I don't know, a hateful content or whatever, or this is much more complex. Let's say that you posted the picture of a broccoli and I need to run machine learning to figure out this is a broccoli, I need to block that. That may take 15, 20 seconds to run.
Hmm?
This is always going to be a background operation. So it doesn't actually give us anything to try to do things immediately. In fact, I would say that on submission, the only process that I have to do is verify the user, so authentication, which presumably you already did. You just need to verify the session token or something like that. A generation of the ID, and submitting the to the queue. Everything else is happening in the background.
Okay, got it. Thank you.
So here's another thing that happens in the background. I'm looking into hashtags in the post, and for each of these hashtags, I'm putting that in the timeline for the hashtag, and that's it. Now we have hashtag support because the concept of timeline is such an important concept. Now, let's talk about how do we handle whales. Who are whales? Those are people who have tremendous number of followers. Now, the code that I had before explicitly checked for that. If you have too many users, I'm not doing that. Because every time that Justin Bieber would post, they would have to go and write to 100 million followers. This puts too much load on the system. I don't want that. In fact, there was one point I remember that Twitter people talked about having to set up a laptop specifically. I think it was Justin Bieber or something like that that had an event and posted a lot, and they had a laptop just to handle his account. That's crazy. So let's see how we handle that. Remember that a whale in this case is defined more than 500 users. And this is a vast minority of the users. So instead, we go the other way around. Where we say, okay, here is your private timeline. This is when I'm going and looking at my timeline. And this is everything that I've written here from all of my followers except the whales. For the whales, I'm saying, give me all of the whales that are followed by this guy. Presumably, even if I'm following all of those, okay, no big deal. But most people aren't going to follow all of the whales in the system. And then I'm going to say, okay, give me the timeline for this guy, for this whale, and just merge it. And this is, again, happening in the client side. I'm not paying for that. All of this is making it awesome target for caching, for CDN, and those sort of things. All of those things are going to push my price down, going to make my system far more scalable. Here is the overall architecture that we have. I'm posting something, I'm sending it to the server, I immediately put it to the queue and tell the user it was accepted. In the background, I'm starting processing that, trying to find broccoli things. I have time to do that. I also have time to do that over multiple processes. I may have, okay, let's do initial validation, let's do a whole bunch of checks that I need to do, and then post that, make this public. And afterward, oh, I need to figure out if I need to add links to, I don't know, Coke or Disney movies or whatever as ads for this post. I can do that after the fact. I have time to do that. In terms of posting, this is what actually happens. I throw that into the local key value store. The local key value store in the region is probably something that is replicated between geographically, but it's still in the same conceptual data center, probably still nearby. I publish to the timelines, and maybe I need to publish a new segment. That's something that can happen again as a background operation. You hear me repeat background operation a lot. Background operation are amazing for scalability because it means that I don't have to do things right now. I have time to do that. And the concept of having time to do that is super important. So now I have behavior. Oh, recommended tweets for this user. Oh, you're following the technology track. Here is the timeline for that. Those sort of things. I got time to do that in as complex a manner as possible. Oh, you want me to show popular tweets? Sure, I can do that, but popular tweets means that I have to wait an hour until they show up. But again, cheap and easy for me to do. Again, here is the rough architectural concept. I have relatively very basic things to have here. In terms of the clients, we are doing a lot client side because we aren't paying for that. Another thing that's very important is the client has a lot of work, but all of that is batch, can be easily cache and optimized server side, which means that from how it's going to look to the user, this is going to look really fast. Notice that in some of the complex things that you may have to deal with, how do you handle deduplication, deleted messages, stuff like that, client side work, merge things, handle duplication, whatever. I don't care. I don't need to worry about that. I can have the client worry about. The code itself isn't complex, and it's pushing it to the client means that the server side distributed environment is far easier to operate with. Now, yeah, yes, I have another 2 slides and I'm done. So we have other things that we have to talk about in building a real application. I intentionally focus on what I consider the most complex things. For example, monetization, go ask the business, not me. Tracking, you throw it in a queue. You handle that at your own leisure. Statistics, there is an algorithm called P encounters, allow you to do those sort of things quite easily. I've implemented that inside of RevenueB. This is something you should just do. But again, this is a dedicated solution for that particular scenario. We're not trying to go generic at scale. This is because to go generic in scale is costing too much. I'm setting out to design a system as is, and I'm trying to figure out what are the maximum number of limits that I can accept, which sounds crazy. Why do I want more limits? And the idea here that more limits makes my life a lot easier because I don't have to do much. Now is the time for questions.
Thanks, Oren. That was really interesting talk and approaching this architectural things from very different angles. We do have few questions, but I think we will cover them in the discussion zone where we heading right away. So thanks everybody, and let's go to the discussion room, and you will have a chance to ask those questions like on your own.
Thank you, everyone.